The electronic CS Digitech motherboard is mounted on all our condensation heaters from the 13 to the 100 kilowatt models. We turn the heater on, and the first thing the motherboard does is to check all the icons present on the screen. It will indicate that it is natural gas, and it will go back to the position it was left in the last time it was turned off. Now the heater is in off position, and this symbol is shown. By pressing the multifunction central button, we can choose what mode we want to set the heater to work in. By pressing it once, it will work as water heater only, then heater and water heater, or only heater. Off. This is the cycle that the central button goes through. If we position the unit in both water and heater mode, in this case the heater icon is flashing. This indicates that the unit is demanding on the heating function. The heater is on, and I can see that from the level and potency displayed. The side buttons on the board can indicate the temperature we have set. For example, on the right side of the screen, we can set the temperature for the water heating. And on the left, the temperature of the heating. With the information button, we access the information related to the unit. For example, D00, which indicates data 00, which indicates the temperature that the water heater is registering at the moment. Then, by moving onto D03, meaning data 03, we see the hertz at which the electronic vent is spinning. Beyond this, once the other temperature probes are attached, the information button will provide all their values and will signal all their temperatures. It is registering at this moment. The same button while in off mode will instead indicate other information. Let's try it by switching it off. Now that the turnet is off, by pressing and holding the information button, we will no longer show us the temperatures revealed by the probes. Rather, it will relate a summary of the last 5 errors that have occurred which the motherboard has saved. E0, meaning 00, is the last in chronological order which has occurred. It indicates that a number 1 error has occurred. With this button, we can scroll between the last 5 errors registered, as arrow 04, which is water insufficiency, and so on. If we want to reset them, all we have to do is press and hold the R button, and 2 lines will appear signaling that the last 5 errors have been erased from the memory. Pressing the I button again, we return to off mode. To enter the parameters menu, we start with the unit in off mode. We press the I and R buttons simultaneously for 7 seconds, like this, and we access these parameters. On this motherboard, there are 25 parameters that can be set. The first parameter, 00, selects the type of heater. The central value indicates the value that is present on this board, which is 4. On the manual that comes with every unit, we can check what each number corresponds to. In this case, it is 34 kilowatts, so by setting the 00 parameter, we are setting the kilowatts of the unit. Moving on, parameter 1 is the type of unit: instantaneous, boiler, or heating. And by modifying the parameter with the buttons on the right, we can change the value of each one and then save it with the central button. At this point, the value chosen flashes for 3 seconds and then remains set, indicating that the board has saved the chosen value. If we return to the off mode by pressing these two buttons, as we turn the unit on, again it will work in heating mode only, and we can see by the icons, the flame icon flashing. Let's go back to the parameters menu. We will put the unit back into standard position, meaning instantaneous, and continue through the rest of the parameters. 02 is the selection of gas, be it methane on 0 or GPL on 1. Parameter 3 is the heating range, like standard at 30 to 80, or reduced, in which case we would be dealing with a grounded unit going from 25 to 40 degrees. Parameter 04 is the increased ramp of the heating, meaning what we decide how long the unit will take to reach full power. Parameter 01 indicates that the board is set to 50 seconds, which is the time the unit will take to reach maximum power. We can modify this value by bringing it up to 100 seconds or 200 seconds according to the corresponding value. Parameter 05 is the anti-colpo di rete function, because the water flow has been activated. What is this exactly? Colpo di rete function is a device that prevents the magnet situated inside from rising. The contact with the microflowstat closes with the magnet on the inside, and making this contact allows the unit to start working, which happens within 2 seconds. Why is this? In some units where the plumbing involved is in close range with the heater, in case the faucet were too close, there could be a pressure change so strong that would make the magnet rise. And if this happens, the function is disabled automatically and the flowstat closes contact. The board makes the heater start, which in turn starts the fan, the circulator, and in some cases turning itself on even if it has not been ordered to do so, because the faucet has been closed, as in this case this function is enabled. The board will start the heater with 2 seconds delay as the contact is closed by the flowstat, stopping the heater from the water when the water supply has stopped. Obviously, this parameter can be enabled or disabled as needed in the case that the user doesn't encounter a problem with the high pressure changes inside the units, as in the case the feed is situated further away, in which case the function were to be enabled the unit would start with a 2-second delay. Parameter 06 is the water heating maintenance, which is disabled in this instance, but we can enable it with the right side buttons. This simply implicates that the time frame of 1 to 150 seconds, the deviation valve remains in summer mode after shutting off the water feed, which is independent on the parameter that we have set that I will be showing you later on. This parameter can be enabled in the case of having continuous closing and opening of the water feed. In this case, the exchanger will keep the hot water flowing in order to avoid the water from getting too cold, yet keeping a comfortable temperature. Parameter 07 is the timer for the heating thermostat, which means that at the moment that the probe reads that the temperature that has been set is reached, the flame will shut off and is turned off. From the moment hence, a timer starts, which is defined by this parameter. These are values corresponding to the number 1 being 5 seconds, 2 is 10 seconds, and so on, until we arrive at 90 times 5, which equals 450 seconds. In this case, we have set to 36, which is 180 seconds, during which the heater will stabilize after reaching the temperature set for 30 minutes. The unit is shut off even though the probe is requesting, which means that theoretically the heater should turn on. This avoids continuous starting and stopping of the unit so that it has a temporal on-off switching, allowing it to work fully. When should we be setting this? It will be lowered in the case of having fine coil, in which case it would turn on after 1 minute rather than 3, maximum 3 minutes and a half, so that the air escape going through the fine coil is cold and the air coming from the unit keeps being warm. Parameter 8 is the post-circulation temperature for the heating. When the heating probe has read that the same temperature has been set is reached, the unit will shut off and the post-circulation will start. The circulator will continue to work for a time that is also set in 5 seconds intervals here. So, also in this case, there's 180 seconds for the circulation to work, as to avoid that the temperatures on the inside of the heat exchanger present when the unit has been turned on won't exceed, further bringing the overall temperature over 90 degrees and making the security thermostat intervene, which is situated right below the outgoing heating probe. Parameter 09 is the timer for post-circulation of water heating. In this case, also expressed in increments of 5 seconds. The value that is set is 18 or 90 seconds. And by changing this value, we are deciding how long the burner should be working in case the water input is closed and the thermoregulator is set in summer position. This way we avoid that the temperature rise within the secondary exchanger to not have limestone residues and therefore adding working lifespan to the secondary exchanger. As we were saying before, the water heating maintenance set previously in the parameter 06 determines how long we want to keep the hot water turning in the secondary exchanger. In this case it is set at 90 seconds, but by modifying this value, not only do we change the post-circulation values, but we change the timer as well between 5 and 450 seconds. Parameter 10. As we turn the heater on, it will automatically start at the minimum speed of the water heating base. This is 55 Hz on the electronic ventilator. This value multiplied by 30 corresponds to the actual spin speed of the electronic ventilator on the water heater at its minimum. We can modify this value even though it is preset by the motherboard, in the possibility of needing a higher or lower power for the water heating. Parameter 11 regulates the maximum value for the ventilator for the water heater. Here, as before, we can access the parameter. The heater remains turned on and is automatically preset by the motherboard at 164 Hz. There are also preset parameters determined by the parameter 0, which defines the heater as a 34 kilowatt model. Here, we have the option of modifying each parameter within the buttons on the right side of the display. Parameter 12 is the regulation of the minimum ventilator value on the regular heating function of the unit. This was also preset to the parameter 0 and is now at 55 Hz, indicating the minimum speed of the ventilator regarding the heating function. I can modify these values with the buttons on the right side of the display in the case the settings require less kilowatts than the preset ones. Parameters 10, 11, 12, 13 are all preset by the motherboard, but can be modified as desired through consultation of the manual. We can see that speeds each corresponds to. This is so we can regulate each parameter according to the power needed by the unit for both water heating and regular heating. Parameter 14 is the slow onset speed, meaning the amount of hertz that the electronic ventilator needs to run and when it turns on to have a good start off without problems and without creating too much noise. In this case it is preset, and we can modify it in the case that we have a very low minimum and therefore 7 seconds from turning on the heater with low levels we may have some noise, in which case we can heighten or lower the value to allow the burner to heat the combustion chamber properly, therefore bypassing these noise problems. Parameter 15 allows us to turn on the Legionella prevention system on or off. In this case, that the heater has a boiler outside or inside the unit, this function is activated automatically. And as seen in this case, it is set to 1. But we can decide to switch this function off, especially if our boiler is reasonably small, which reaches a 60-degree temperature quickly every time it is turned on. When this parameter is switched on, every 7 days, during which the water heater is turned on, if the instant temperature of the boiler is lower than 60 degrees, the heater will turn on to reach this temperature. Parameter 16 is the set point for the external probe. In other words, the setting of the climatic curve in the moment that we attach the external probe to the heater's clamp through parameter 16, we will need to set or modify the climatic curve with these two buttons with values between 0.1 and 30. On every instruction manual there is a reference table that shows the external temperature, the desired internal temperature, and the value needed to be set consequently on the climatic curve. Parameter 17 is the selection of the measuring unit for the temperature. In this case it is set to 1 as we are dealing with Fahrenheit. Although, if we need, the motherboard can be mounted in countries where the temperature is measured in Celsius. Parameter 18 enables the piloting of industrial base from 0 to 10 volts. Therefore, by connecting to the motherboard with a pilot value of 0 to 10 volt independently from the regulation made through the buttons on the unit, we can have control on the temperature or the power of the heater. Depending on the tension that the control unit sends to the motherboard, we can therefore set this value to 0, as we see here, disabled, causing there to be an absence of the external control unit, or at 1 in the temperature control mode, or 2 through power control. Parameter 19 is the minimum heating set point. Thanks to this parameter, we can modify the default range of the minimum heating. As we said previously, this is between 30 and 80. In this case, 30 can be changed to a higher or lower value, allowing us to have an easier and more precise decision on what value to set our final heating at. Parameter 20 is the setting of the maximum range of the heating. As we mentioned before, the maximum is 80, and we can lower this value with a range that we can choose between 40 and 88 degrees. We can lower this range to avoid that my setting is always on high, which could cause limestone deposits that can ruin parts of the unit over the years. We can lower this value with the buttons on the right side of display. Parameter 21 is the set point of the maximum for water heating, meaning that this is the case, the maximum range that I can have for water heating, which is now set at 60 degrees, although we can change this value from 45 to 75 degrees in the case that the heater is used, for example, for industrial purposes. This will modify the maximum temperature for water heating by influencing the management of the unit for the water heating probe reading. Through parameter 22 and the following parameters, we can regulate the back and forth flow of the hot water. Thanks to a pump or non-traditional circulating modulator, the 22nd parameter indicates the difference between the maximum temperature for outgoing and incoming through two separate probes that measure and help us decide what the DDT should be, set to between 10 and 40. When the detector signals 0, this means that we have a traditional rather than a modulating system. Parameter 23 indicates the minimum velocity for the modulating pump. When the delta T is about to reach the desired limit, the pump will start to spin at the speed we have set by percentage in the 23rd parameter. Parameter 24 regulates the speed at which the pump must spin in the case that the difference between the in and outward flow is breaching the preset range. In this case, it is set at 100%, but we can obviously lower it down to 70%. The last parameter, number 25, is the period of control of the delta T between the in and the out flow, which is expressed in seconds and is set in this case by 30 by default. Every 30 seconds, the motherboard reads the temperature revealed by the outward probe, then the inward probe, and makes the balance of the two factors and determines at what speed the circulator must spin, therefore modifying the speed of the ventilator. This value may be modified from a minimum of 20 seconds to a maximum of 100 seconds. Once these values have been modified, we return to off mode by holding down these two buttons. On the unit's display, we can read the temperature as well as the functions that are activated automatically or thanks to the qualified technician. For example, the function 07, which is the chimney sweep function, can be activated by a technician in the following manner. Turning the unit on, holding the R button for 7 seconds, then we will see F07 displayed. The heating icons will flash and so will the technician icon. In this case, the chimney sweep function is used to make a combustion analysis because it makes the heater work on full power on the heating function, ignoring the reading of the output probe, and it does so for 15 minutes. If we want to stop this function before the 15 minutes are up, all we have to do is turn the unit off and it will be automatically disabled. Function F8 is the heater's antifreeze function, which we will now simulate. It starts automatically when the heater goes below a certain temperature, in this case 8 degrees, at which time F08 appears on the display. The heater turns on and brings the minimum temperature to 30 degrees. Once the output probe reads 30 degrees, F08 automatically comes off the display and we'll keep seeing the heater's temperature. Function 09 instead is the antifreeze function for the water heating and works the same way as the previous one. When the probe for the water heating reads a temperature lower than 4 degrees, F09 will start. the water heating icon flashes and the unit starts up and brings the temperature up to 8 degrees. When the temperature read by the water heating probe reads 8 degrees, the unit shuts off and F09 stops. Function 28 is the anti-legionella, which we spoke of previously. If this function is enabled, every 7 days the heater will bring the temperature of the boiler up to 60 degrees and F28 will appear on the display. Function F33 is the unit's venting cycle function. It starts automatically when the unit is turned on for the first time by activating the vent in cycles of 40 seconds and deactivating for 20 seconds during 5 minutes. Here we can see F33 because we have turned the unit on for the first time. In this case, with the gas feed open, the valve doesn't open. Rather, it stays shut and only the circulator runs. This gives the technician who is installing the unit the possibility of removing all air from the unit, avoiding the formation of bubbles which may damage the heat exchanger. This function is disabled automatically after the 5-minute cycle has ended, and if we take out the power during this cycle, when we plug it in again, it will start over from 0. At the end of the 5 minutes, the heater turns on, the burner starts, and this way we have eliminated all the air contained inside. If the water supply were to be missing in the water pressure gauge, the probe will detect this and we will see water missing error message displayed. And F33 will come for 2 minutes and the pump will be activated for 40 seconds and deactivated for 20 seconds in cycles as to remove automatically the air bubbles that may have remained in the unit. Function anomalies. In the case of missing gas feed or a broken probe for the detection of a broken gas valve, the unit will automatically relay these errors as it is auto-diagnostic and we will see the E1 displayed. In this case, we have shut the gas valve off on purpose to illustrate this mechanism. We will now running second test. We will see E01 on the display. There it is. As well as E01, it will say reset. This means that the error can be reset by the user directly by pressing the R button. Indeed, as we can see, if we press the reset button, we turn the gas valve on. As this was the problem manifesting E1, the unit will turn on again and work normally, since we have solved the problem. Obviously, for other reasons, we should have to replace a component. If the gas valve is defective, we will have to replace it. Same issue if the spark plug were damaged. Error 02 is the intervention of the security thermostat. In this case, we are removing a wire to simulate the opening of the security thermostat. After 2 seconds, E02 will appear on the display. This is also resettable by pressing R. It will come off, but since the contact is still not present, it will start E02 all over again. This means that the water present within the tubes is at a temperature higher than 95 degrees, which is the temperature limit for this thermostat. This can be verified because the condensation exchanger is clogged, the circulator is stuck, or simply not functioning, or the thermostat itself has quit working. If we close the contact again, we will reset the error and the unit will automatically start up again. Error 03 is the intervention on the security thermal fuse. This will shut off reaching 102 degrees when the fuse temperature exceeds such a level. We will now simulate this problem by removing the cable. We have opened the cable for the thermal fuse and we instantly see E03 displayed. This is also resettable. When we reset, we will change out the damaged fuse and press R, and the unit will restart. What can lead to this E3 for the thermal fuse? The thermal fuse itself may be broken, the cable is detached or interrupted, or there's a lack of water circulation. All these causes must be verified before substituting the thermal fuse. Error 04 means lack of water in the unit. This means that the pressure in the unit is insufficient, therefore below 0.2 bar. It can lead back to a defective water pressure gauge, a lack of water in the unit, or the cable for the pressure gauge being broken or not connected properly. In this case, we will not see the reset button icon. Rather, we will see the service one, which means that even if the user tries to reset with the button R, the unit will not attempt to start off again, since it knows that there is a defective part inside that needs fixing or replacing. Error 05 is related to the heating probe, and it can mean that the probe is broken, the connection of the probe is disconnected or wet, and also in this case we will see service appear on the display, which implies that we must have a technician fix the damaged component. When the component has been replaced and the heating probe is functioning, the service sign will come off automatically. As we can see. We will then continue to visualize the temperature reading as normal. Error 06 is related to the boiler or water heater probe, which means that there is either broken, disconnected, or wet. And even in this case, the service sign will appear, meaning that we need a technician to intervene to verify the problem. As soon as the component has been replaced or fixed, we will see the regular temperature displayed again. Error 15 is related to the return probe. In the case that we have a modulating circulator unit built into our water heating group, we will need to install a probe for the return. If this probe is broken, ruined, or simply not properly connected, we will see E15 come up on the display. At the moment that we reconnect the return probe, the error will disappear from the display. Error 16 is related to the electronic ventilator. There is either a cable disconnected from the ventilator or the ventilator itself needs replacing. In this case, as the previous ones, the service warning will appear indicating that a technician must intervene. Error 18 is related to insufficient or complete lack of circulation. As soon as the probe situated on the output for the reading reads a temperature that steeps rapidly by 9 degrees within 2 seconds, the display will show E18. The first thing that needs to be verified is that the circulator is working. Touching it with our hand, we can feel whether it is functioning or not. Otherwise, we can unscrew the bolt on the ventilator circulator and we can verify if it is working or not. If it is not working, we should check the electrical connections, and if from this we deduce that 110 volts are coming through, we must replace the circulator's motor. We will dismount the 4 bolts, these 4, situated on the ventilator, as we saw earlier in the components replacement guide. In the case of replacement of the motherboard, after we have connected and activated it we will see E22 on the display. This is the parameters programming error, which simply means that the motherboard is telling us that after being replaced, no parameters have been modified. To get rid of this error, we'll have to do is get to a parameter. Switching by pressing these 2 buttons, we'll access the parameters menu. We save the first or modify the 00 parameter that relates to the model of the unit in question, in this case a 34 kilowatt, so we can confirm. Exit the parameter menu like this, and as the unit is then turned on, the E22 will automatically disappear. To verify that the probe situated on the water heating is working correctly, all we need is a simple tester. We put it on the OMA, direct the 2 pointers to the 2 connections of the probe, and see what reading we get. In this case, the reading is 6780 ohm, which corresponds to around 36.5 degrees. And as we can see on the display, we have the same reading. In the case that E02 should appear, we can verify the temperature on the security thermostat with our tester directing the 2 points of the thermostat's connector, like this, and verifying whether there is a flow. If there isn't one, it means that the security thermostat must be replaced.